Okay, what we are looking at here is an old Lyman Mold Master XX, Mold Master 20 pound capacity here. This is the little attachment I made for my PID. So here's the deal. This has a standard, I don't know what kind of plug they call these. It was for like electric skillets and stuff. It's kind of this thing here, and it plugs in, and I don't know if you can see, there's a mica spacer in there, insulator, and it's wasted. I mean, I gotta fix this thing. So I was at the auto parts store today talking to some of the guys down there, and I was telling them, hey, I need to get some kind of insulating material that can withstand, I was just throwing around the number 850 degrees because it says it's 850 watts, but to me, to get up to 775, which is what I set my PID for, is normal. So I just kind of wanted a little extra window. So they handed me a sheet of carburetor gasket, which I'll show you in a second. So we're going to take this thing apart and see if we can repair it. I think a lot of people have trouble with these things. This, you can see it's wasted. We'll take a look when we get in there, and it should be a pretty short video here. So anyways, we will get this thing fixed and I will be back. Okay, so let's take this thing apart. I see 1, 2, 3, 4 screws holding on this thermostat housing, and if this is anything like the Model 61, which I also have, that's a 10 pound capacity pot, all steel. I use that for zinc, casting zinc, and I basically had to bypass the thermostat to get it to go hot enough with the PID. So it should be all the same in there. There should be 2 connectors right from here going to the housing element. So let's take this thing apart, and it should be pretty easy to, whoops, and as you can see, this ain't gonna win the beauty contest. But this thing, oh man, it casts. I like this better than my brand new Lee 420. It just, I don't know, it just seems to work better. It doesn't drip, it doesn't clog as much, but let's see, we're getting down to the wire here. Okay, there's the 4 screws, and this thing is, okay, so you can't see, one of the wires just came off. Okay, so you get, so there you go. Okay, let's just, so we got left, it's kind of like an R for right, but as you can see, this thing is a freaking mess. This is like mica, and you try and plug this thing in too many more times, forget it. So we're gonna make a gasket spacer or insulator. Okay, so let me show you here. So I got this. This is to make gaskets. I think this is specifically for carburetors, but let's just do a little close-up here. If you can read that, max operating temp 1200 degrees Fahrenheit. This should be good. And it's a little bendy, but I think if I cut a few strips, stack them up, and drill our holes, we should be good to go for a good solid repair and get this bad boy back in business. So give me a second. I'm going to shut the camera down. I'm going to cut, I don't know, maybe three strips. So what I'm going to do, and maybe I'll do this on camera, I'm going to dismantle all this stuff, take our measurements, and or maybe just trace them onto this, and then cut maybe 2 or 3 strips just to get enough rigidity, I guess is the word, so when I'm trying to plug this thing in, I'm not gonna, you see what's going on there? So I don't know if you can see, but this is mica, and I think the proper name is muscovite. I used to be a geology major in college. Whoops. And so yeah, this stuff just flakes off, and if you guys ever grew up with wood burning or coal stoves and you had windows, that's what this stuff's made out of. It can withstand massive amounts of heat. It's not conductive, but it's I don't know, I was looking around online to find some. I couldn't find any, so that's why I'm gonna try and do this out of a gasket material. So I guess let's see if we can just do this right now. We're gonna unscrew this, and I did go to the hardware store and I got some longer screws for this, so I think we're gonna need a longer screw if we're going to stack up a few pieces. So looks like we got a washer there. Actually, let's just undo this other one. Okay, hold on. Alright, there she goes. So now we got this piece off, and it looks like the whole thing, oh come on man, let's see if, so I actually don't know when they made these. I'm gonna guess late 70s, and this thing's really stuck in there. I guess we have to unscrew it even though it doesn't have a, oh there we go, oh man. Alright, there's one piece that's broken. So yeah, it was on the way out for sure, there's no doubt. Okay, here's our second piece now. Okay, we got this. All kinds of shit falling out. So, I'm just going to disconnect these two pieces, okay? And I don't think there's any plate there. Obviously they have to be separate, so I'm gonna cut down the camera. I'm gonna shut it off. I'm gonna measure out a piece that's gonna be basically the length we need, and it doesn't really matter. This is the important part, getting the length right for that. So I'm gonna cut. All right, let's just see here. What a mess. So I got this gasket material, I got some shears, and I will be back with some pieces. Okay, still working on this thing. I just thought I'd get back on film and show you here. So this stuff is like super fragile. I mean, it crumbles apart. It's just, yeah, so you basically gotta unscrew these things, and I need to take a measurement of our two holes there for the prongs. That's what we're going to drill out. So if anybody has one of these old pots, I think this might be a way to fix this without finding, I don't even know what this would be called. It's Mica Insulator board or something. But I couldn't find anything this thickness, and this thing has been on this probably since 1975, so it's old. It's stuck on there. Okay, we're getting there. Alright, so anyways, I just wanted to show you guys the process that it may not come off easily. You may need a couple of sets of pliers to get this thing going. There we go. But man, this thing is just, it's in pieces here. That doesn't matter. All we need is the measurements for those two holes. These we can size up once we get it all mounted. So I'm going to come back. Okay, so we need to get a measurement here of this plate, and this plate was right in here, and so we can, I don't know if you guys can see the line here, we can get a measurement right off of this and use this too. So let's just see here what this would be, and this doesn't really matter, this length. Here, let's go this way. So we got about 2 3/4 inches, somewhere in there, and that doesn't matter as long as we get it long enough. And then we gotta get these two holes. Whoops, get these two holes pretty much exact. So let's see here. I think I can go even a little more, it doesn't even matter. Okay, so I'm going to just use this edge, just kind of trace. Again, doesn't need to be perfect. This part doesn't need to be perfect. And so I'm going to cut this out with some shears here. And maybe we'll go, let's see if this should do it. Yeah, perfect. And maybe we'll go a few pieces thick and get the rigidity we need. So it's not bad. Maybe 2 or 3 of these though will be the trick, which is what we are going to find out, because honestly the pot is not really usable at this point until we get this thing fixed. So there's going to be 2 pieces. Whoops. Let's get that cut. Let's see what 2 is like. That's better. Let's go 3 pieces. So I'm just going to go here. Go this way. Let's get that thing lined up. Now, 3 pieces is pretty good. It's still a little flexible. The bottom line is, if this doesn't break over time, which, you know, it might, let's go one more piece, see what 4 would feel like. So let's just cut this end first. Use this to kind of measure what we're doing. Make a little cut here. Whoa. All right. Okay, we got 4 pieces here. That's getting pretty good. Will it last? We don't know, but will it work? I think so. All right, I'm going to come back with these drilled out, ready to go. Okay, so just to get back to you here, use this piece to trace holes, which we'll drill out, and then I could center it like this, turn it over, and mark from the holes in here the spacing. Whoa, the spacing we need to drill out. And then once I've drilled this one out, I can stack 3 of them up. I cut 4, but when I put a few in here, it's pretty solid. When this gets screwed down, I think this is going to last a long time. So, okay, now I will come back with them drilled. Okay, so we've got a few pieces here drilled out. I just basically, use this to measured the holes off of this, stacked up a few pieces. I'm going to try and go 3, and I think this is going to work. So we're going to put this back together and see what happens. Okay, so we got these pieces of gasket cut, and I got 3 of them. And one thing I noticed, so here's one of these electric prong pins, and so the way this goes, you can see on this one, we're going to connect like this. If I put this through this way, okay, let me just kind of show you what I was looking at here a second ago. Let's just say I put this thing in here. Let's just say that was all the way in, and I'm plugging it in. How is it going to stop getting pushed out? So I think what I'm going to do is put it like this. It would be on this side. And then I'm going to put the other ones over it. Hopefully you can see what I'm doing here. And then the screws are going to mount, and that way when you're plugging this thing, Jesus, what a nightmare here. When you're plugging this thing in and out, it's got something to stop on. Otherwise, if I've got it through here, and I'm in here like this, over time, this is probably going to loosen up, and it's going to push through. And I think, see if I can find a piece of this mica here. I'm not exactly sure because the thing was in pieces, but I'm thinking it was embedded in there, so, it can't go anywhere. So, what I'm going to do, I just wanted to show you guys that this is going to be the first piece, and it's going to be three strips, okay, 3 strips of gasket, and we're going to put this thing together like this. So I guess the way to go is take this thing off, alright, and try and keep track of everything here so I can put it back together. Okay, so which one is this one? The one not marked L. So let's see. And I think this is the way to go on this, I really do. Okay, we're just gonna get this bugger out. And like I was saying, once you work this thing in and out a few times, it's gonna loosen up. So we're gonna go in this way with the first one. Alright, I've got this little lip to stop that. It can't go in. I'm going to stack these other 2 up. I'm going to reconnect all our pieces, and then I will be back on camera. Okay, let's take a look where we're at here. So, let me unscrew this piece so I can show you guys. So there's 3 pieces of gasket. The first one, these prongs are on the lip, okay, and then so I put them in that way. These other 2 went on from this end. This is going to go in here like this, okay. Let's see if I can. All right. Now, when I screw this down, it'll be solid, but I'm pushing on this with some good pressure. This thing ain't going to go anywhere. So let me put this thing back together, and we'll fire it up and see what happens. Okay, before we reinstall this, I thought I would just show you guys what we got here. I ended up going with 4 strips of the gasket. I haven't even put on the washers or nuts on this, but check it out. I mean, I'm pushing with some good pressure. You can see, let's see if I can, you can see it flexing right in there. But again, I haven't even put the nuts on this thing, so I think we're gonna be good. You know, the thing is, it's I don't know when they made these things, 1970s. I think at some point I dated this 1975, but you know, to get this mica board or whatever you'd call it, I don't know. I mean, unfortunately, this country doesn't really manufacture stuff the way we used to, and so my first thought was getting mica windows for a wood-burning stove and stacking them up. Couldn't really find much to even get close to this thickness. The other thing was trying to find a piece of asbestos tile, but you know, again, so if anyone out there has got an old Lyman 61 or the excellent Mold Master 20, my only complaint with this is they spell mold with a U. What the hell's up with that? God damn. Anyways, but yeah, there's not a lot of options for some kind of an electrical insulator that can take more than 200-300 degrees Fahrenheit heat, and you know, you go looking around, you start to find that out. But anyways, I'm gonna just reassemble this off camera. You guys saw, so I'm gonna put washers and nuts there, tighten them down. This is gonna reconnect my and then we're gonna put this thing on. I think I got some trash lead in here. Let's take a look. Oh yeah, we'll see if we can get that melting. And geez, what a mess in there. Back to bullets. Alright, I'll be back. Oh, one last thing I forgot to note about this is maybe take a picture of your connections before you take everything apart, and you know, but this is pretty solid now. It does show a little bit of a gap. Let's see if I can angle that right in there, but who cares? I mean, you're basically, what you're going to end up doing is you're going to plug this thing in once for your session and unplug it. I mean, that's freaking solid. And you do want to get this measurement right. This doesn't need to be exact, meaning you have to get the screws to line up, but you'll notice all my cuts in here, I didn't measure. I don't care. I'm just going to eyeball it. No one's ever going to see it. It's designed to be functional and solid. This has got to be good. If you still have your piece, trace this. If you don't, or it's so wasted you can't, you could probably just trace that. So, all right, let's fire it up. Okay, we're back. The Lyman Mold Master 20 is back in business thanks to this carburetor gasket material. You guys can probably get this all over the place. I got it at an auto parts store. Just make sure your max operating temp, I'd say any gasket material is going to be over 1,000 degrees, which is more than enough. I did run into a snag. The thermostat apparently has stopped working. The pot would get up to about 200 degrees, and I put it on the PID, which, you know, there's no lead in there, so when it gives you a reading, it's kind of reading the air, but it wouldn't go beyond that temperature. And I got this pot, I think maybe a year and a half ago or 2 years, and when I got it, the temperature would fluctuate, and I went in to the thermostat housing, and I basically used a product called Deoxit to deoxidize the contacts on the switch. But when I was having trouble this time, I opened it up, and there's little ceramic spacers in the thermostat, and they're cracked now, which they weren't before, so I'm guessing that's the problem. I'm not sure what the temperature is at the bottom of the pot. My PID is saying 408, but it's hotter than that. There's lead melting in there right now, but the PID is not in lead. So anyways, I think what I'm going to do, so I disconnected the thermostat here. I'm running direct from the pot coils to our plug to the PID. PID is right down there. And I'll do a video on that. And I've got a Lyman 61 pot as well. And maybe I'll just have both of them in the video. It's a really easy thing to do, to bypass the thermostat completely. But you need a PID. It needs to run somehow. So that's basically it. Here, I'm going to shut off the PID here. And I'm going to unplug this and just, or maybe I'll just turn it around and show you guys the, man, that thing's hot already. So there it is. I mean, here, let me see if I can lower this thing even a little bit more to get a nice shot. But the repair worked. And is it going to last forever? I don't know. But it's working now. And here, I'll just plug it in, see if I can show you the, I mean, the thing ain't going nowhere. That's a solid repair. And we got the Lyman Mold Master 20 back in business. All right, you guys have a good day. See ya.